Polling is complete and the launch team has been given the go for launch. The countdown will resume approximately 2 minutes from now. From T-minus 4 minutes until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team call out the Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and MUOS 4 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engines ignite and perform a health check, followed by the ignition of the 5 solid rocket boosters to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
This is Atlas Mission Control. The countdown clock has resumed and we are proceeding towards a 6:18 a.m. Eastern Time liftoff.
Three minutes.
Securing LO2 topping.
Atlas change to flight pressure.
250.
FTS internal.
This is Atlas Mission Control at T-minus 2 minutes 31 seconds and counting. Once the rocket lifts off, it will take only about 34 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
FCS launch enable.
This is Atlas Mission Control at T-minus 1 minute 32 seconds and counting. The launch vehicle, payload, ground systems, and Eastern Range are still go for launch.
120.
Orca's armed.
FCS count started.
115.
Reduce CCS for launch. Roger.
110.
Vent valves locked.
T-minus 1 minute and counting.
Status.
Range green.
40.
Stable at step 3.
T-minus 30 seconds and counting.
ECS reduced for launch. Roger.
25.
Status check. Go Atlas.
Go Centaur.
Go MUOS.
15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the 4th Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Roll program is complete. SRB chamber pressures have plateaued. Mach 1. And booster has throttled back up right on schedule. Engine response looks good. Pump speeds are good. Injector pressures are as good as well. Max Q. Body rates look good. Engine has now achieved the proper throttle setting. Response looks good. And we have begun to throttle down. Engine response looks good as well. SRB chamber pressures looking good. Looking for burnout momentarily. And we have SRB burnout. And booster has now throttled to maintain a 2.5 G throttle in preparation for payload fairing jettison. Coming up on SRB jettison. And we've jettisoned 1, 2, and all 5 solids. Looks like a good separation. Now flying Q alpha limited steering. Vehicle rates look good. RD-180 continues to perform well. Closed loop steering has been enabled. Body rates continue to look good. Current altitude is 41 miles, downrange distance 58 miles, current velocity 4,992 miles per hour. RD-180 continues to perform well. Pump speeds, injector pressures look good. Body rates controlling right down the middle. Bus and battery voltages are good as well. And the RCS pyro valve has been fired. That system's now pressurizing to flight levels. Signatures look good. Booster continues its throttle to maintain 2.5 Gs in preparation for payload fairing jettison. Current altitude 67 miles, downrange distance 148 miles, current velocity 7,719 miles per hour. And we have payload fairing jettison. Looks like a clean jettison. And we have CFR jettison. Booster has throttled back up. Engine response looks good. All systems are nominal. Coming up on our 4.5 G throttle segment. And now throttling to maintain a 4.5 G throttle. Boost phase chill down is underway. Boost phase cooldown's complete. And we have BECO. Engine shutdown looks good. And we have retros and stage separation. Looks like a clean step. We have LOX and fuel pre-start on the RL-10. The GN2 purge firing on the RCS is underway. We have ignition and full thrust on the RL-10. Centaur steering has been enabled. Body rates look good. LO2 tank pressures have been vented down as expected. RL-10 performance looks good. PU has gone to closed loop control. Engine response looks good for that. Centaur is currently flying at 120 miles in altitude. Downrange distance is 595 miles. Current velocity is 13,827 miles per hour.
This is Atlas Mission Control at T plus 5 minutes 53 seconds. We've just heard Marty Malinowski confirm successful completion of the early phase of today's mission. All systems continue to operate nominally. The mission is currently in the first of 3 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 7 minutes. I'm now joined by Commander Paul Benishek from the Navy's Communications Satellite Program Office. Commander, thanks for joining me.
Thank you, Steve. It's a pleasure to be here.
Commander, what benefits does MUOS bring to the table?
Well, MUOS works like a smartphone network in space, vastly improving secure satellite communications for mobile users and the U.S. forces. MUOS provides users a global, on-demand, beyond line-of-sight capability to transmit and receive high-quality voice and mission data on an Internet Protocol-based system.
We're here for a satellite launch today, but I understand that there's much more to the system.
Absolutely. MUOS is a complex orchestra comprised of a 5-satellite constellation, 4 ground stations across the globe, an integrated waveform, radios, and complex software to manage the network. Additionally, more than 55,000 currently fielded radios and terminals can be upgraded to be MUOS capable, with many requiring just a software upgrade.
Commander, this is a Navy-led program, but only services can use this capability.
That's correct. The U.S. Navy plays a key role in national space efforts by providing narrowband satellite communications for the Department of Defense. While MUOS was designed for mobile users who require worldwide secure voice and mission data at higher data rates, these capabilities are also available for ships, aircraft, and ground vehicles used by all U.S. military services.
Commander, what kind of improvements can warfighters expect to experience?
That's a great question, Steve. So, the MUOS constellation will provide users with 10 times more communications capacity over the legacy system. You see, legacy satellite communication systems allowed users to talk as long as they were within the same satellite footprint. MUOS allows troops all over the world to talk, text, and share mission data seamlessly without having to worry about where they are in relation to a satellite.